All right. So I'm going to pick up where we left off. And what I really want to do is we're going to do a couple division problems with complex numbers. And then we're going to move into the very last section of this chapter, which is just solving equations with fractions, which honestly is pretty easy. Okay. I think what we're doing now, like the adding, subtracting, and all that stuff, is more difficult than solving. It really is. All right. But we can't do any of that. We can't solve it all until we understand how to do this stuff first. All right. So here we go. Let me change to my pen that I want. And remember, if I'm moving too fast, just let me know. So here's our first problem. We're going to divide 8 over 5 divided by 3 and 1/5. Okay? So like I said, sometimes you need to take a step back and ask yourself, okay, I got two fractions. What's happening between them? Well, we're dividing. So we know the method on dividing would be, number one, rewrite the first fraction. Number two, change division to multiplication. And then number three would be to write the reciprocal of the second fraction. But there's the problem. Our second fraction is a mixed number. So what do you think I'm going to do with that mixed number first? I'm open to suggestions here. Let's turn it into an improper fraction first. So first, let me write convert 3 and 1/5 to an improper fraction. So remember, we take the whole number times the denominator and add the numerator and divide it by the original denominator. So that's going to be 16 over 5. So my problem turns into 8 over 5 divided by 16 over 5. Now that we've done that, it's just straight up dividing fractions. So we rewrite the first fraction. Division changes the multiplication. And we multiply by the reciprocal of the second fraction. Now, we try to reduce first. Notice I'm not going to do 8 times 5 and 5 times 60. I'm not going to worry about that. What I'm going to do is break down the 8 and break down the 16. Next, I'm going to write one big numerator and then one big denominator. Now, I'm going to simplify if I see a number that's the same in the top and bottom. So it looks like I can simplify 3 sets of 2 and then 1 set of 5. So 2 over 2, that goes to 1 over 1. 2 over 2, 1 over 1. 2 over 2, 1 over 1. And then the 5 over 5, which is 1 over 1. So in my numerator, I'm left over with a 1. In my denominator, I am left with a 2. So the answer is 1/2. Are there any questions with my technique and how I did that? All right, let me give you one to do. Very similar to what we just did. I want you to divide 5 over 7 divided by 1 and 2/5. I'm going to go grab a drink of water. All right, how we looking? Who got an answer for me?
I have
35 over 35? And what does that reduce down into, Amber? 1. So did we get 1? Anybody else get 1, or did you get something different?
I got 25 over 49.
25 over 49. Okay, so we're getting some different answers here. So let's go through it together. How about that? First, take a step back. We got a fraction divided by a mixed number. I know I need to get rid of that mixed number first. 1 2/5 converts into 7 over 5. Right, Asma?
Yes.
Perfect. So I'm going to rewrite this as 5 over 7 divided by 7 over 5. Now, from here, I need to stay true to the technique. Don't skip steps. Step 1, rewrite the first fraction. Step 2, division changes the multiplication. Step 3, multiply by the reciprocal of the second fraction. Now, simplify. Well, if I look at the very first fraction, 5 over 7, the 5 is prime, the 7 is prime. There's nothing I can do there. Same thing with the second fraction. So I know no matter what, as soon as I multiply these two numbers, my answer is already in reduced form because I could not simplify anything in this step. Therefore, the answer is 5 times 5 is 25. 7 times 7 is 49. Amber, do you see where you made your mistake?
Yeah.
Not a big deal, just as long as we learn. I think you forgot to reciprocate.
Yeah, I did.
All right, are there any questions? All right. So let's do a problem that looks like this. All right, I want to see what we come up with here. So we have the quantity 11 minus 7 squared divided by 11 squared minus 7 squared. Okay? So if you take a step back and you look at this problem, you got a fraction. It's just in the numerator of this fraction, it looks a little complicated. Same thing in a denominator, okay? But if you really think about it, you just have a numerator and a denominator. Let's simplify that. Let's only focus on the numerator. So that is the quantity 11 minus 7 to the second power. We know, according to the order of operations, we need to do the work inside the parentheses first. So 11 minus 7 is 3. That is incorrect. 11 minus 7 is 4. Am I right? Boy, I wish I can use the "it's Monday" excuse, but that was just a dummy move on my part. And now, 4 to the second power is 16. Okay? I am going to do the same exact thing with my denominator now. 11 to the second is 121. Minus 7 to the second is 49. Are there any questions so far? All right. 121 minus 49. Does anybody know what that is? Me neither. That's why you do it. Write it down. 121 minus 49. Definitely got to borrow. 11 minus 9 is 2. 10 minus 4 is 6. So I come up with 62. So far, so good, everyone? Now from here, you always need to make sure your answer is simplified. 16 breaks down into 2 times 2 times 2 times 2. And I think 62 is 2 times 31. Would you agree? All right, from here, just reduce what you can. In this case, we can only reduce one set of 2. So 2 over 2 reduces. What's left over in a numerator? 2 times 2 times 2, which is 8. And then 31 in my denominator. I'm sorry, Asma, what did you say?
I just did over 51.
Oh, okay, I'm sorry. I didn't even hear you. My bad.
Okay.
All right, how are we looking? Pretty good? Yes or no?
Yes.
All right, all right. Yeah, this honestly is not difficult. I think what makes it hard is and this isn't just, like your individual problem. This is everybody's problem, and it's even my problem. Sometimes we just move too fast, and we need to slow ourselves down, get organized, and just think about every step. Okay? And the only way to really get good at that is by practicing. That's it. So I'm pretty much done with this section. I want to talk about solving equations with fractions. All right? Which is the very last section here. So let's go ahead and do that. So solving equations with fractions. All right, and this is our last section here. So the first type of problem that I want to look at is a problem that we're all familiar with. All right? Actually, let's make it this a 9. We'll make it a 9. All right. How would we do this problem?
We would minus 9 on both sides.
Todd, do you remember what that technique is called?
No?
It's called the subtraction property of equality. All right, make sure you remember that.
Did you say it again, please, teacher?
Yeah, so why? I'm sorry. It is called the subtraction property of equality. And we would have learned that all the way back in, I think, chapter 2 in the language of algebra. In fact, it's chapter 2, section 3. That's how far back it goes. Okay? Now, if we can do this problem, y plus 9 equals 5, we know to subtract 9 from both sides to isolate the variable. There is no reason why you cannot do this problem. Notice this problem is y plus 9 over 16 equals 5 over 16. How do we approach this problem?
The same way, but the denominator stays the same.
Exactly. We do it the same exact way. I love the way you said that, Amber. So we're going to subtract 9 over 16 from both sides. Now, we know on the left-hand side of this equation, 9 over 16 minus 9 over 16 is 0. So we isolated the variable. Here's the problem. It's that right-hand side. We have 5 over 16 minus 9 over 16. And we know when we subtract fractions, we got to have a common denominator. Well, is it a common denominator? Yes or no?
Yes.
Absolutely, Autumn. Thank you. So, since the denominators are the same, the only thing we got to worry about is subtracting the numerator. 5 minus 9 is negative 4. Now, obviously with fractions, you always want to make sure you're completely reduced. So, off to the right, This is going to be negative. 4 is 2 times 2. 16 is 2 times 2 times 2 times 2. Reduce what you can. 2 over 2 turns into 1 over 1. So it looks like my final result is y equals negative 1 over 4. So you're going to hear me say this a lot, and I've already said it a lot, but you're going to hear it even more. Did I teach you anything new here? I mean, did you know about the subtraction property of equality? Yes or no? You already knew about that. You already know how to subtract fractions. So did I teach you anything new with this problem?
No.
No, I didn't. It's just we're bringing everything together again, okay? All right? So I'm going to give you one to do now on your own, okay? Very similar to this one. Please try that. Solve 4 over 15 equals 8 over 15 plus y. Okay, anybody got an answer yet?
Yes.
What'd you get, Todd?
Negative 4 over 15.
All right, I think it looks good. I think it's good. So let's go about this. First, we know we have 4 over 15 equals 8 over 15 plus y. So our variable is on the right-hand side of the equation, which means we need to isolate it. So we're going to subtract 8 over 15 from both sides. I know on the right-hand side I get the letter y, and off to the right, I'm just going to write 4 over 15 minus 8 over 15. Now, the scenario we're in, I love because the denominators are the same. So I just got to worry about the numerators. 4 minus 8 is negative 4 over 15. And if you need to, write it out. 4 is 2 times 2. 15 is 3 times 5. Notice nothing reduces, so I know my answer doesn't reduce. So negative 4 over 15 equals y. Good job, Todd. Okay. Are there any questions so far? All right. So here comes a problem here, and I think if we're good, we can guess what the answer is. Okay? So let's try this first. All right. Hold on one sec. All right, sorry about that. Molly, my wife, just got back from walking Arthur, and we found a tick on him. So now we have to get the tick off of him. So she's going to do it. And she's gagging already like she's going to throw up. All right, such is the pleasure of owning a dog in Western PA. So here we go. Solve x divided by 5 equals 2. Now, if we think about this problem, what number divided by 5 equals 2? Could we guess what that number is?
Maybe 10?
Yeah, I agree with you, Asma. The answer is 100% x equals 10. All right? But guessing is just not good for us. We need a systematic way to do this. Now, remember in the past, you had the addition property of equality. You had the subtraction property of equality. You had the division property of equality. Now, if you forget the division property of equality, that's this problem. 4 times x equals 12, where you would divide both sides by 4 to give you x equals 3. So let me repeat the ones again. Addition property of equality, subtraction property of equality, division property of equality. What's the only one I didn't say?
What's the one?
Multiplication property of equality. So that's what we're going to have to use for this problem. So let me show you what that is first. So I'm going to scroll up and I'm going to write it underneath.
Oh, stop. Stop, Arthur.
Honey, if you just wait like 15 minutes, I'll do it. Okay? I know you don't like doing that. All right, so here's our multiplication property equality. And this is what it says. If you have two things that are different and they're equal to each other, then you are allowed to multiply both sides by any number you want, as long as that number is the same on both sides. Now, for our problem,
Don't bite.
x over 5 equals 2.
No.
Notice what I'm going to do here is I'm going to multiply both sides of my equation by the denominator. Because when I do that, actually, let me just rewrite the problem, because I want everybody to watch what's happening here. When I multiply both sides of my equation by whatever number that denominator is, notice on the right-hand side, 5 times 2 is 10. That's the easy part. Actually, to be honest with you, that's the hard part. The easy part is on the left-hand side, even though it looks more complicated. 5 times x over 5. The whole reason why we chose to multiply by 5 is because if you look, we have a 5 in the numerator and a 5 in the denominator. And we know that'll always reduce to a number 1. Does that make sense, everybody? So on the left-hand side, you're left over with x. So here, we have a systematic approach on how to solve problems. We're no longer guessing. We know if we have a problem, and I'm going to do another one off to the right-hand side here. If we have a problem such as f divided by 4 equals 20, we know the multiplication property equality says I can multiply both sides by anything I want. So what I'm going to choose is whatever my denominator is. So on the left-hand side, I multiply by f over 4. And on the right-hand side, I multiply the 20 by 4. Now, the left-hand side is the easy part, because you have 4 in the numerator and 4 in the denominator. So they reduce. What's left over is the letter F. On the right-hand side, you actually have to multiply that out. 4 times 20 is 80. Is that making sense, everyone? Okay, like I said, I think this is much easier than everything we've been doing. All right? So the next problem we're going to look at. Sorry, am I moving too fast?
You just wait 1 minute, please.
Yep, I'll wait a minute.
Okay.
Did you put any... You didn't do it? Okay.
No, you're not on mute.
Oh, that's okay. So you didn't put Vaseline on top?
I did. I got 2 Q-tips on it.
Okay.
There's a little spot on it right now.
Yeah, I can see it. So note if one of your animals ever gets like a tick on them, you could put like Vaseline on the tick and it'll actually like suffocate the tick because ticks need to breathe. So it'll back itself out over time and then you could just safely remove the tick. All right. Or you could just Google how to remove a tick.
Clear nail polish.
Yep. Okay. Because we live in Western PA and the tick population is outrageous. All right, are we good?
Yeah.
Okay, look at another one now. So here's another example. We're going to solve P divided by -8 equals -40. Now, once again, we need to use the multiplication property of equality here. So I'm going to multiply both sides by -8. Give myself some space here. Okay? Once again, in my personal, humble opinion, the left-hand side of our equation is actually the easier side because you have a -8 in the numerator and a -8 in the denominator. They reduce. So you're left over with the P on the left-hand side. The right-hand side is harder. A negative times a negative is a positive. 8 times 40 is 320. All right. Any questions so far?
I don't.
All right. Good. So now let's look at a situation like this. If we wanted to solve -c equals 41, okay? We do have to be a little bit careful. Because remember, we want to isolate the variable. And what I mean by isolate the variable, I want that variable to be a positive number. Currently, that variable is negative. In fact, you could think of it like this on the right-hand side. -1 times c. So if you look at the problem like that, we are going to be using our division property of equality. And we're going to divide both sides by -1. But once again, you have -1 in the numerator, -1 in the denominator on the left-hand side. So that's going to give me c. And then positive 41 divided by -1 is -41. Okay? How are we looking?
Good.
Good? Okay. Now, the last couple problems here, we're going to do about 3 of them, are going to be the most difficult ones. Okay? However, if you've been paying attention to the words that I've been saying, it's actually very simple. So I guess, I don't know what I'm trying to say here. Just watch. Just put the pencil down and just watch. All right? So here we have a situation. 2/5 times n equals 14. Okay? Now this problem is different from the other ones we've been looking at. In fact, let me scroll up just to show you. Notice with this problem, the p was in the numerator. Notice with this problem, the x was in the numerator. Notice with this problem, the f was in the numerator. In the one we're looking at now, n is not in the numerator. Well, technically it is, but we have a fraction out front. However, our process does not change, okay? If you were to guess, I'm going to multiply both sides of this equation by a number. What do you think that number is? Just take a guess. I wouldn't multiply by n. I'm trying to isolate the n, so I'm not going to touch that. What number am I going to multiply both sides of this equation by?
2/5.
If I multiply by 2/5, that gives me 4/25. Notice nothing changes there, Todd. It's a good guess. In fact, it's a great guess because it was wrong. And we know we can rule that one out. So it's a great guess. It's a good mistake. Well, look at the previous problems up here. What did I multiply by? With the very first one, this one. What did I multiply both sides by?
5.
Why? Why do we multiply both sides by 5? What do you think? Anybody? Why do we multiply both sides by 5?
So that both numerator and denominator are crossed out.
Good. Why do we multiply for the second problem right here on the right-hand side? Let me erase it. And I'll zoom in, so that's the only one we're looking at. Here, why did I multiply both sides by 4?
So that they can cross each other out.
So I can reduce the denominator. Good. For this problem, why did I multiply both sides of the equation by -8? So I can reduce the -8. Notice in every single instance, whatever the denominator was, that's what I multiplied both sides by. So, what am I going to multiply both sides of the equation by here? Y. You're correct.
Same thing, we can cross the 5. We can put the 5/1, cross the 5 with 5.
We can reduce the 5. Notice what's left over inside the parentheses now.
2.
2n. 5 times 14 is 70. So now I need to take this one step further because I have 2 times n, which means I divide both sides by 2. So that gives me n equals 35. So now we're getting into 2-step processes. First step, multiply both sides by the denominator. Second step, solve for the remaining variable. Okay? The key is to get rid of that denominator because let's be honest, we hate fractions in this class. I don't think one person in this room would sit there and go, Mr. Float, I'm like you. I love fractions. Let's have a fraction party where all we do is fractions all night long. I don't think anybody's coming to that party. And that's okay. That's fine. I know, I'm a little weird. I like fractions a lot.
Let's just say something urgent would come up. And I'd start forcing it.
I'm washing my hair that night. All right, let's try another example. So we have 5/6y equals 15. First step, I'm going to multiply both sides of my equation by what?
6.
By 6. Now the question becomes, why are we doing that? I agree with you, but now you got to answer the question. Why are we doing that?
To take out the numerator and denominator.
To take out the 6. That's the whole reason why we do that. Our first step is to get rid of the thing that we don't like, a denominator. So multiply both sides by 6. Now, if you scratch them out, you can physically see what's left over. On the left-hand side, it's 5y. On the right-hand side, 6 times 15 is 90. Now, we take a deep breath. We read the problem again. 5 times y equals 90. We know we need to isolate the variable, and we always do the opposite operation. 5 times y, the opposite operation, is division. So, on the left-hand side, that's simple. The 5's reduce. You're left over with the letter y. On the right-hand side, 90 divided by 5 is 18. Are there any questions so far? All right. Last problem of the day. Last problem of the chapter. When's your test? Next
Monday.
Next Monday. Excellent.
I had a dream that our test was today,
Well,
so I thought it was today.
I wish it was today. Because I gave an exam the first period, or at 8 o'clock. So I played Call of Duty while the exam was going on. So I would have been playing Call of Duty for 3 hours straight, which is a very good day for me. But anyways, here's another problem. -7/9 times w equals 84. Okay? So what am I going to multiply both sides of my equation by?
9.
Good. Now remember, everyone, we multiply both sides of the equation by 9 so we can eliminate the denominator. We can reduce it. So the 9's, we can scratch them out. That gives me -7w on the left-hand side. And then on the right-hand side, I already did the math. 9 times 84 is 756. What's my next move? Divide both sides by -7. Thank you, Amber. So on the left-hand side, you have -7 over -7. We know that reduces. You're left over with a w. On the right-hand side, a positive number divided by a negative number is negative. And then 756 divided by 7 is 100, 108. Right, Maria? You can just give me a thumbs up if you want. Perfecto. I like thumbs up. I think it's like old school. All right. That's it. That is it for today. That is it for the chapter 4. You are now officially done with fractions. However, they're always going to be there. Okay? So, next chapter is going to be chapter 5. You're going to see fractions in chapter 5. Okay? Because there is a relationship between a fraction and a decimal. There is. Okay? And then in chapter 6, when we start dealing with percents and proportions, we're going to see it again. All right? The key is to be able to take a step back, look at the problem and say, okay, I'm adding two fractions. Well, adding fractions, common denominator. Or I'm subtracting fractions. Oh, subtracting fractions, common denominator. And then how do you do that? If you're multiplying, simplify first, reduce what you can, multiply the leftovers. Division is just multiplication all over again. It's just you got to rewrite the problem first. If you don't like mixed numbers, convert them into improper fractions. That's fine. Then go ahead and do your math. When you solve, read the problem, okay? Read it out loud. -7 divided by 9 times W. As soon as I see that fraction and I see that denominator of 9, I'm going to multiply both sides by 9 so I can get rid of it. That's my goal. Okay? So I'm done for today.